This video, we're going to use some fundamental identities to simplify some expressions. Remember, your fundamental identities are your SOHCAHTOA definitions, your reciprocal identities, your quotient identities, and your Pythagorean identities. So other things that you'll have to memorize, we'll have additional problem sets later, but these are the group of identities that we call fundamental. So let's go ahead and use some of those. You can find them the way that they're written in your textbook. One of the most fundamental identities in trigonometry is that sine squared of an angle plus cosine squared of the same angle is 1. And that's going to be our first rule that we use in 16, is that sine squared of theta, which they have as 25 degrees, plus cosine squared of the same 25 degrees is going to equal what? That's going to equal 1 by the Pythagorean identity. Another version of that is that 1 plus tangent squared is equal to secant squared. So we can rearrange that to say secant squared minus tangent squared is going to be 1, which is what we have in number 17. That secant squared of 35 degrees minus tangent squared of 35 degrees has to also be equal to 1. Number 18, we have cosine of 80 degrees times secant of 80 degrees. Remember that secant and cosine are reciprocals of one another. That automatically means that they're going to multiply to give me 1. But if you want to see that for yourself, let's cancel the common factor there. 1 times 1 is 1. 1 times 1 is 1. 1 over 1 is 1. Number 19, we're going to use a quotient identity, that tangent of 20 degrees minus sine of 20 degrees over cosine of 20 degrees. Sine over cosine is tangent. And tangent minus tangent is 0. So now we're going to look at number 20. If sine of theta is equal to root 3 over 2, let's find tan theta. We're going to use our definitions and identities to help us with this, but let's draw a triangle here. Here's theta. Sine is root 3 over 2. And we don't want to draw the triangle. We want to use identities. So it's an acute angle though, it's up here. So theta is between 0 and 90 degrees. So all 6 trig values are going to be positive. So sine squared theta is going to be 3 over 4. And if I have sine squared plus cosine squared is 1, then 3/4 plus cosine squared is equal to 1, and cosine squared is 1/4, and cosine is going to be 1/2. This was an unknown angle, but that's correct. Now let's go ahead and use sine theta is equal to 5 over 13. So we're going to find cosecant theta by taking the reciprocal, like so. And that was number 21. For 22, cosine of theta is 1/2. And we want to find secant theta, which is the reciprocal of 1/2, which is 2/1 or 2. For 23, we have that cosine theta is equal to 3√10/10. So let's find cotangent squared, or I'm sorry, cotangent theta. We can find, we need to find tangent and then take the reciprocal to find cotangent, or we need to use the identity for the definition for cotangent, that it's cosine over sine. So let's find sine by saying that this is cosine squared is 9 times 10/100, and that's 9/10. Sine squared plus cosine squared is equal to 1. So sine squared is equal to 1/10. So sine theta is equal to 1/√10, which is the same as √10/10. So cotangent is going to be cosine over sine multiplied by 10/10. And I get that cotangent theta is 9/√10. And I'm going to rationalize. And I get that cotangent of theta is equal to 9√10/10. That was number 23. Let's go ahead and look at number 24. Tan of theta is equal to 3. Find sine of theta. So let's go ahead here and say that if I find tangent squared, because I'm going to have to find a way to find cosine here since I don't know it. That this is going to be tangent squared is equal to 9. 1 plus tangent squared is equal to 1 plus 9. So secant squared is equal to 10. So secant is equal to √10. Cosine is equal to 1/√10 or √10/10. So if I want tangent, which is sine over cosine, times cosine will give me sine. So tangent, which is 3, times cosine, which is √10/10, is equal to 3√10/10, and that's going to be my sine value. That one was a little tricky. You might know some other ways to do that. If I just set up a triangle here with the ratio, I just wasn't supposed to draw a triangle this way, but triangles are the easiest way to do this. And I use the Pythagorean theorem. Then I'd get a 10 on a √10 on that side. And then sine is going to be 3/√10. And we would rationalize our denominator, and we would get 3√10/10, which is the same answer that I got. I just needed to do it by way of identities and not by drawing a picture this time. Let's go ahead and keep going here. Tan theta is equal to 4 over 3. They want us to find cosine of theta. So again, let's find tangent squared theta. It's going to be 16 over 9. 1 plus tangent squared theta is going to be 16 over 9 plus another 9 over 9 is going to be 25 over 9. So secant squared theta is going to be 25 over 9, making secant theta 5 over 3, and that makes cosine 3 over 5. If cotangent of theta is equal to 3 over 4, we want to find sine of theta. So we can square cotangent and add 1. To get cosecant squared, which means that my cosecant is 5 over 4, and take the reciprocal of that to get my sine value is 4 over 5. My secant, in this case, is 13 over 12. And we want to find cotangent. So let's say if I have 1 plus tangent squared, that's secant squared. So let's find secant squared. That's 169 over 144. So 1 plus tangent squared is equal to 169 over 144. I'm going to subtract 1 and subtract 144 over 144 from both sides, giving me that tangent squared is equal to 9 minus 4 is 5. 6 minus 4 is 2. That means it's my tangent theta is 5 over 12. And that tells me that my cotangent is 12 over 5. And if I want to find cosecant now, cosecant is 1 over sine. So this is cosine over sine. Let's see if I have cosine here. Is 12 over 13. So cosine over sine times 1 over cosine will leave me with 1 over sine, which is cosecant, which is what I want. So cosine over sine, which is cotangent, times my 1 over cosine, which is secant, is going to give me 13 over 5, which is going to be my cosecant. If secant theta is 13 over 12, and we want to find cotangent theta, well, I just did that a minute ago, but let's do it again. That secant squared theta is 169 over 144, and if I say 1 plus tangent squared is equal to secant squared, and tangent squared is secant squared minus 1. So secant squared minus 1 minus 144 over 144 is going to be tangent squared is 25 over 144, which makes tangent theta equal to 5 over 12, and that makes cotangent theta 12 over 5. If cosecant theta is equal to 2 root 3 over 3, which is the same as 2 over root 3, then cosine is going to be, let's see, so cosecant squared is going to be 4/3. That means that sine squared is 3/4, and sine squared plus cosine squared is equal to 1. So 1 minus sine squared is cosine squared. So cosine squared is 1 minus 3/4. Cosine squared is 1/4. And when I take the square root of both sides, cosine is 1/2. One last problem in this problem set. If tan theta is equal to 7 over root 15, then we want to find both sine and cosine. So let's try and do that. So tangent squared is equal to 49 over 15. If I add 1 to that, 1 plus tangent squared equals 15 over 15 plus 49 over 15. So secant squared is going to be 64 over 15. So secant is going to be 8 over root 15, which makes cosine root 15 over 8. If cosine is root 15 over 8 and tangent is 7 over 15, then sine over cosine is equal to tangent, and sine is equal to tangent times cosine. So sine is equal to 7 over root 15 times root 15 over 8. And sine is 7 over 8. So there we go. That's it for this section. Next time we'll come back and solve some problems with the complementary angle theorem.